Namaskar, Vande Mataram. Today I am going to discuss how to construct Kaleidoscope in GeoGebra. You are seeing some grid which is different from Cartesian grid. This grid is known as isometric grid. Here you have 30-degree rising axis, 30-degree falling axis and vertical axis. So this becomes very useful if you have to do some hexagonal construction, or if you have to simulate some 3D object, let's say cuboid, then it is possible for you to do this. I'll show you how this is done. So if I take this polygon and show something like this, so it's possible for you to construct this one shape, then next it will be like this. So I can easily draw a cuboid with the help of this. This is a very useful thing. And then if you want to put this diagram somewhere, it's possible for you to do it. So this is how it's possible for you to take care of three types of grid: Cartesian, isometric and polar. In polar you have r and theta coordinates. Data entry is permitted in in polar as well as Cartesian. Data entry is not permitted in this particular type of grid. Okay, so you all know this Kaleidoscope. See, say for example, supposing I show this particular thing, this text I want to show you. Okay, so this toy has a history of about 250 years. All of us must have enjoyed it and also must have made it. I had made it when I was a child of maybe 8-10 years. It just needs 3 glass strips. The mirrors are not required, please note. Put these forming an equilateral triangle. Okay. Now one end is to be closed with round glass. Put some colored transparent beads, pieces of bangles. Put one more round glass and close with a translucent paper because light should be permitted to enter. The rotation shows beautiful patterns of objects and 12 distinct images. Beyond that, there are infinite images, but those are little faint images. So I'll close this to avoid distraction. Now we are going to put objects here. Okay, let me put one object and say I put red object here. Now this object will get primary images in these 3 glass plates. These 3 glass plates. Okay, and then those will get secondary and tertiary images. So let us see those one by one. So I have got one image. Please see that this has a perfect image. Now I don't need this grid, so I may close this so that it becomes clean. Okay, right. So see this reflection. So this I call as primary image. There will be primary image here also. So we'll see that. So primary image, third primary image. Now this primary image will have secondary image here as well as here, and similarly these ones. So let us do that. So this is the primary image. secondary image, two secondary images. Here two secondary images will come, and here again two secondary images will come. Right. Now if I move any of these objects, say this object I move, I cannot move the image, I cannot move the object. Please see that all those images, they move. Primary, secondary. And then finally here, both these images put up one image which is known as tertiary image. Okay. Right. Now please note that if this is not exactly 60 degrees angle, then here you might get two images, one by this and one by that. Okay. But we normally arrange this in 60 degrees, so we get 1 plus 12, so 12 images and one object, and when it comes in corner or anywhere, they form some beautiful pattern. Now I'll put another object, okay, third object, okay, and any of these objects I move, I go on getting different kinds of patterns. Okay, so this is the beauty of Kaleidoscope. Now I have named this for you, these images. Say this is the object, image 1. I'll remove one of these things. Okay, so this is image 1, image 2, image 3. Secondary image 4, 5. Okay, 6, 7. Then you have 8, 9, and then tertiary images 11, 10, 11 and 12. So this is how the construction of the Kaleidoscope is done. I hope you like this. If you need some particular problem or some demonstration, mail me. My email address is simple. Okay. So it is vasantbarve@gmail.com. @gmail.com. So if you send me a mail, I'll be glad to what is happening, why it is removing this thing. Say VASANT. Okay, vasantbarve@gmail.com. So on this mail address, if you send your queries, your response, or you need something, right, I'll be glad to show this. So I hope you enjoyed this particular demonstration.